This is super, super cool. If you are somebody that's had muscle pain, and you've had muscle pain for a while, what makes somebody have muscle pain for a long time? What makes it chronic? If you have acute muscle pain or that lasts only a few days, how does it become chronic? How does this process of chronicity, we could say, occur? Well, they investigated just that at a recent study that they did, at the University of Campinas in Brazil, or Campinas, however you say it. I didn't see an accent mark, I think Campinas. And they wanted to see the mechanism by which this happens. How does that acute muscle pain become chronic? Well, there are many different mechanisms involved, but they found one novel one. And it involves macrophages. What are macrophages? Well, they are immune cells that go to the site of injury, right? Or when there's muscle damage, they go there. When people are sick, things like that. And they can eat away debris, right? When the alarms are on, it sends a bunch of macrophages there and they take care of some problems. And there's a lot of other immune cells, of course, and things involved in an inflammatory response, right? And when we think of pain, we think of inflammation. The two go hand in hand, right? So the P2X4 signaling pathway, the name doesn't matter, in these macrophages is responsible, at least one thing, one mechanism by which that acute pain, that acute muscle pain becomes chronic muscle pain. And they found something that can deactivate that pathway. That is natural. That is really cheap. At least in terms of money, it's free, really. But it takes a lot of effort. It doesn't take a crazy amount of it to deactivate the pathway, but it takes some. Maybe you guys can guess what it is, right? Well, it's exercise. Here's another reason to exercise, you guys. P2X4 signaling pathway macrophages. Deactivates them, right? And so it helps to put that process to a halt, right? It doesn't let that acute muscle pain become chronic. And when we think of exercise, how does it reduce pain in general? Because we know that is definitely the case. We've talked about trials where they showed a bunch of osteoarthritis patients, right? Joint degeneration arthritis, as you guys know, common arthritis, where there's, the cartilage is wearing away and whatnot. Where these people, they would either exercise for 3 days a week, and not like crazy intense. You're talking 40 to 70% of their max heart rate. Just 3 days. Or they took ibuprofen every day. And it was like 600 milligrams, I believe, for a month. At the end of the month, the group that had greater reductions in pain, it was the exercise group. The ibuprofen didn't do anything long-term. No surprise there. It's a Band-Aid. Right? So, how is exercise doing this? Well, we know that exercise reduces inflammation. That is well known. And reducing inflammation is going to definitely help with pain. So that's a good thing, right? And you can also reduce inflammation by eating healthy foods and all that stuff. We can talk about that. But it reduces inflammation, improves circulation. All right, improving blood flow, that seems like a good thing. Getting some blood pumping, right? Helping to promote the release of happy chemicals, like serotonin, for example. Your happy hormone / neurotransmitter or brain chemical. Endorphins, things that make you feel good, put you in a good mood. So of course you'll be in less pain. You're in less pain when you're in a good mood. It seems like that. It strengthens the muscles that surround your joints. So if my muscles are really strong that are supporting my joints, well then my joints are going to be able to function better. And they'll be able to endure the same load more easily and they won't be as stressed. So it reduces pain in that way. But one really interesting way also is joint lubrication. So joint lubrication. So how does exercise help to lubricate your joints? Let's first talk about a joint. Let's go through some very simple anatomy here. 2 bones, okay? See, these are our leg bones, right? It's our tibia, the lower one, and this is the femur, the big one up here, beneath the quad, right? And so can you just have the bones hitting each other? Well, that wouldn't be smart, right? So the body's a lot smarter than that. So it has what we call articular cartilage. It's like a cap on each one, all right? So now you got a cushion. In the knee, there happens to be a meniscus also, right? Medial, lateral, we're not going to talk about that. We have this cartilage on the bones. Now, in between them, we have synovial fluid, right? So we have this fluid, and it lubricates the joints. The fluid also helps to nourish the cartilage, right? It delivers nutrition to the cartilage to keep it nice and thick and healthy, help prevent it from wearing away. It supports waste removal from the cartilage. So we need to, and the joint itself, we need to remove waste in there too, right? So the fluid does a lot of good stuff. But is stagnant fluid a good thing? What happens when there's stagnant water in your pool? Right? Mosquitoes start to lay eggs and all this stuff goes wrong, right? What happens when your blood flow becomes static? Things start to clog up, doesn't quite work as well. What happens when you don't start your car for a while? For years. It's not going to run the same. Maybe it won't even start, right? You got to keep things pumping. In general, that is true. For health and for how machines operate. And we are a biological machine. So what do we have aside from this, right? Bones, cartilage, fluid. Is that fluid just all over the place? No. Synovial membrane, encasing it. If the bones were here and here, picture they're still there because I have only two hands, arms. There's something here that is a fluid-like membrane that directly surrounds that fluid. We call that the synovial membrane, or the synovium, you could say. Now what's outside that is a thicker membrane. We call this the joint capsule. This is more fibrous. It's kind of like a bandage, right? So picture like a thicker type of thing, less elastic, we could say, surrounding the synovial membrane. And then outside that, and you have the bursa, and you have, ligaments attaching bone to bone, and tendons attaching muscle to bone, all that stuff. But how is the fluid in the joint made in the first place? And do we stop making it when we're kids? No, you're making it throughout life. That process could slow down at some point, but we are making that fluid almost constantly. And the way we do it is we have these little blood vessels in the joint capsule. And they release what's called ultrafiltrate. It's just a fancy word for collagen and hyaluronic acid, prostaglandins. They're just fatty acids, like little fats in the body, right? Lubricant, these are all things, the name precedes it, right? Helps to promote the production of something that lubricates joints, right? I love when there's a name like that. So it is made of that stuff, right? Is this thing that is coming out of blood vessels in the joint capsule, this ultrafiltrate. And then it goes from the joint capsule, gets squeezed out of there, and it goes through the synovial membrane, and it enters into that fluidy area, right? And that is how synovial fluid is produced. And it's produced. So is exercise producing more of this? Well, not necessarily, but it's doing one very important thing. Again, that stagnant fluid is not a good thing in general. And this exercise is helping it to move in the joint around that cartilage and to circulate. And if it's moving and circulating, then it can nourish the cartilage better, right? It can lubricate it, of course. It can help to eliminate waste. And so exercise, aside from deactivating that P2X4 macrophage pathway, is just so good for your joints. And it is so effective at reducing not only joint pain, but also muscle pain, as they showed in this trial. So really, really interesting stuff, And again, I try to give you guys 100 billion reasons to do healthy stuff. This is another one. Go exercise. Even if it means going for a walk every day or whatever. Go do something. We are meant to move, baby. That is for damn sure. Who do we got on here? Let's say what's up. It's going to get dark soon, so we got to go inside. It's raining, but under a tree. It's working out. And it's nice out. I wanted to come out here. Ronald, how you doing? The Ben Gomez. Adrian Martinez. Paul, what's up, dude? Maybe I'll see you tomorrow, man. Saladin, Ricardo, Sivia, Ash, what's up, baby girl? Life Wrangler, and Antonio. Appreciate the love. As for now, that's all we got for you, folks. We'll see you tomorrow, baby. Not sure where, not sure when, but we'll see you then. Have an awesome rest of your night. Thank you so much. Happy Friday. Happy Wend Wellness. See ya. These are fun.